Hello everyone, this is Dr. Lennon. This is the final exam review, so basically this is just some questions off of our two tests, and it'll be our final assignment. So let's go ahead and have a look at the first one. It's multiplication and division of fractions. So when you multiply fractions, you just multiply their numerators and multiply the denominators. You can cancel beforehand to kind of make the numbers smaller. So what I mean by that is 5 will go into 10 twice, so we can cross off the 5, make that a 1, and then cross off the 10, make that a 2, because 2 times 5 is 10. And with 3, we can do the same thing going into 18. 3 goes into 18 6 times. So that'll just leave us with 1 on top, 1 times 1, and on bottom 12. Division of fractions works similarly, but first we have to switch it to a multiplication. So we do that by copying down the first fraction, flipping the second fraction, and then changing the division symbol to multiplication. And then everything goes the same way as before. So we can do some cancellation here. Again, 7 will go into 21 3 times, and 2 will go into 4 1 time. 2 will go into 4 twice. So we end up with 2 times 1 on top and 3 times 1 on the bottom. So 2/3 is your answer for part B. For number 2, we have to simplify, but now we're dealing with addition of fractions. So for the first one, so the way this works is if they have a common denominator, you just add the numerators. And if they don't have a common denominator, you need to find a common multiple. So for A, they have a common multiple, so we just go ahead and add the numerators, and we get 6 over 9. 6 and 9 are both divisible by 3. So to put that in lowest terms, 6 divided by 3 is 2, and 9 divided by 3 is 3. So our final answer here is 2/3. B is a little bit trickier because, well, sorry, let me organize this a bit better. So I'll write an A here, part A. Part B. B is a little bit trickier because they don't have a common denominator. So you need to find a common multiple of 24 and 16. There's a few ways to do that. I think most students find it easiest to just kind of like list multiples of each. So if you go 24, 48, 72, and so on, you can keep listing multiples of 24, then do the same thing with 16, 32, 48, and so on. We see that 48 appears on both lists, so that makes it a common multiple. So for the first one, what you want to do is multiply by a fraction equal to 1. That's going to make the denominator 48. So we multiply by 2 over 2. And since 16 is since 48 is the third element on the list of 16, we're going to have to multiply 1 over 16 by 3 over 3. So we end up with, so to multiply again, multiply numerators and denominators. So we get 10 over 48. Plus 3 over 48, and then we can just add the numerators, and we get 13 over 48. And 13 is a prime number, and 48 is not a multiple of 13, so that's our final answer. Okay, so for number 3, we have a problem with percentages. So we want to know 65% of what number is 18. So remember our key kind of associations here. Of translates to multiply. What number basically is replaced by x, and is means equals. So with those associations, we can quickly translate this into an equation. The one thing you want to do is, instead of using 65%, turn that into a decimal. So we do 0.65 times x equals 18. So once you've got that set up, it's really easy to solve. We just divide by 0.65 on both sides, and we get our answer. So it doesn't come out to anything, it's a repeating decimal essentially. So what we're going to do is we're just going to round it to 2 places. So I put a little squiggly equals there, so that means basically we're rounding it. It's an approximate value, it's not an exact value. So if we round this to 2 decimal places, it comes out to about 27.69. So for number 3, or for number 4 here, we're just solving a linear equation. So the only thing we really have to do is distribute and then collect x's on one side and regular numbers on the other. So we distribute on the left, 4 times 3x is 12x, and then 4 times 4 is 16, so this is plus 16. And on the right-hand side, we have to not only distribute the 5, but also the negative symbol. So this comes out to negative 5x, and then negative 5 times 3 is going to be minus 15. Okay, so let's move the x's to the left and the regular numbers to the right. So I'll add 5x to both sides. So then my x's are only on the left-hand side of the equation. So now I have 17x plus 16 equals minus 15. And then to move the 16 to the right-hand side, we want to subtract 16 on both sides. So I end up with 17x equals minus 31. And then I just divide by 17, and I have my final answer, which comes out to negative 31 over 17. And that is that. For number 5, we want to find 3 consecutive even integers whose sum is 234. So that means when you add them together, they're 234. Now, the thing about even integers is they're all divisible by 2, which means they're essentially all 2 apart. So consecutive means they're right next to each other. So like 6, 8, 10. Those would be 3 consecutive even integers. But we don't know exactly what they are. So if we want to list them, we could list them by saying, okay, let's call them x, x plus 2, and x plus 4. So notice with, say, 6, 8, and 10, 6 plus 2 is 8, and 6 plus 4 is 10. So we can write them all down by saying, okay, they're x, x plus 2, and x plus 4. So then we get our equation by just adding those 3, x plus 2 plus x plus 4, and we know when we add all 3 together, we get 234. So then that simplifies x plus x gives us 3x, and the 2 plus 4 add together and make 6. And then we can solve that linear equation. So we can do that by subtracting 6 and then dividing by 3. So when we subtract 6, we end up with 3x equals 228, and then dividing by 3, we end up with x is equal to 76. So basically the 3 integers are 76, 78, and 80. And that's it. So the key to this problem is just writing it down in an organized way. Okay, so for number 6 here, we have we're trying to find the missing angle of a triangle, and that's all we really need to remember here is the fact that the sum of angles in a triangle add to 180 degrees. So if you can remember that, then we're pretty much done. So we know that 80 degrees plus 35 degrees plus our missing angle, let's call it x, has to add up to 180 degrees. Then we just go ahead and solve. So 80 plus 35 adds up to 115 degrees. And then from there we can just subtract 115 degrees on both sides. So we end up with x is equal to 65 degrees, and that is the missing angle. Okay, so for problem number 7, we want to use the Pythagorean theorem to find the missing side. So basically, what does the Pythagorean theorem say? It says in a right triangle, meaning we have a 90-degree angle, which would be the bottom right corner here. A squared plus b squared equals c squared, where c is your hypotenuse, meaning the side opposite the right angle or the longest side of the right triangle. So in this case, if you square the shorter sides and add them, we're adding 7 squared plus x squared, and that has to equal 25 squared. So then we solve this equation for x. So go ahead and square those numbers. So 49 plus x squared is 625. And then I can subtract 49 from both sides. So I end up with x squared is equal to 576. And then to find x, you can just take the square root of both sides. So the square root of x squared would equal the square root of 576. So if you check that in your calculator, x will come out to 24. And that is the length of the missing side in this problem. Okay, so for the last one, we have two cars leaving Cincinnati, one going north at 65 miles per hour, at least an average speed of 65 miles per hour, and the other south at 70 miles an hour. And we want to know how long it takes them to be 472.5 miles apart. So basically, we know distance is equal to rate times time. We're going to use that here. So if you think about the distances, we have the distance of one going, well, technically it would be up and down since we're going north and south. So we have the one car traveling this distance and the other one this distance. So basically their distances is going to be the sum of the two parts. So the sum of the car traveling north is going to be 65 times t, and the distance traveled south by the second car is going to be 70, that rate times the time of t. So if you add those two respective distances together, we should get the total distance of 472.5. So that's the equation we need to solve. 65t plus 70t equals 472.5. So we have like terms on the left, so we can add them. So we have 135t is equal to 472.5. And then we divide by that 135, and we get our final answer. So if you plug that into your calculator, 472.5 divided by 135 is 3.5. So it takes, and that answer is in hours because that is the time travel. So that's it. That's the last question here. Again, this is just material from the first two tests, and the final exam will be very similar in terms of material, order of questions, and length. So if you have any questions, just let me know. This is Dr. Lennon signing off.